Separation and Processing, CRISP 2025. We request you all to kindly take your seats as the proceedings are about to begin.
Good morning, ladies and gentlemen. Good morning, ladies and gentlemen. On behalf of the Department of Fuel, Minerals and Metallurgical Engineering, IIT in Dhanbad, I, Darshan, and my co-host Sonal extend a very hearty welcome to each one of you. We are gathered here today for a momentous occasion, the inauguration of CRISP 2025, a conference dedicated to the pivotal field of critical metals. We are delighted to announce that our esteemed chief guests and honored dignitaries have arrived. Let's welcome them with a warm round of applause.
With great honor, we now invite the chief guest for today, Dr. V.K. Surasat, member of Niti Aayog, Government of India, to come onto the stage. May I also request the director and patron, Professor Sukumar Mishra, and the advisor of CRISP 2025, Dr. Dhruv Kumar Singh, to kindly escort the chief guest onto the stage. We would now like to invite Professor Shatrughan Soren, Chairman of CRISP 2025 and Head of the Department of Fuel, Mineral and Metallurgical Engineering, to come onto the dais. We would now request the convener, Professor Aarti Kumari, to the dais, and co-convener, Professor Vishnu, Teja, Mantripragada, to come onto the dais.
As a token of appreciation, we now call upon Renessa and Harshit to present bouquets to the dignitaries. We humbly request Director Sir to welcome the chief guest with the floor. Can we have a huge round of applause for them? We now kindly request Dr. D.K. Singh to felicitate our director with the floor. Yes, sir. We would also request the HOD sir to present a floral bouquet to Dr. D.K. Singh in this occasion. We now request the convener of CRISP 2025, Professor Aarti Kumari, to present a bouquet to the HOD of our department.
As is the tradition, we shall begin this auspicious event by seeking the blessings of the Almighty. The ceremonial lamp symbolizes that this is spelling of darkness and the dawn of knowledge and wisdom. I kindly request all the dignitaries on the dais to please come forward for the lighting of the ceremonial lamp. Thank you, respected dignitaries. May the light of knowledge illuminate our path throughout this conference and beyond.
Now, to commence the proceedings for the event, I would like to invite Professor Aarti Kumari, the convener of CRISP 2025, to deliver the welcome address and share her insights on the conception of this conference. Ma'am, the stage is yours. Please welcome her with a round of applause.
Good morning, ladies and gentlemen. A very warm welcome to all of you to our beautiful IIT ISM campus for this 3-day national conference on critical metals, recycling, innovation, separation and processing CRISP 2025. It is a great honor for me to welcome Dr. V.K. Saraswat, Honorable Member, Niti Aayog, Government of India as a chief guest of this event. It is a great privilege to welcome you, sir. On behalf of the organizing committee of CRISP 2025, I welcome Dr. Sukumar Mishra, Director IIT ISM Dhanbad and Patron of CRISP 2025, Professor Shatrughan Soren, HOD, Department of Fuel, Minerals and Metallurgical Engineering and Conference Chairman, Dr. D.K. Singh, Visiting Professor at IIT ISM Dhanbad and Conference Advisor, Dr. Deependra Singh, former CMD, Indian Rare Earth Limited and President of Rare Earth Association of India, Dr. Raghavendra Tiwari, Distinguished Scientist and Director, Material Group, Bhabha Atomic Research Center, Dr. M.B. Verma, former Director, AMD and Consultant, National Security Council Secretariat, Sri R. Sarvana Bhavan, Deputy Advisor, Niti Aayog, Dr. Alok Avasthi, Head, Materials Group, BARC, Dr. Sanjeev Tyagi, CEO, GMDC Science and Research Center, Gujarat, Professor K.K. Singh, Professor, IIT BHU, Professor Vishnu Teja, Co-Convener of CRISP 2025, distinguished dignitaries, industry leaders, faculty members, researchers, students, and members of press and media. It is my great honor and privilege to welcome you all to the inaugural session of CRISP 2025, a flagship event of national relevance being hosted as a part of centenary celebration of IIT ISM Dhanbad. As the convener of CRISP 2025, I take great pride and joy in seeing this long envisioned idea transform into reality. This conference was conceptualized to addressing pressing need of our times, the sustainable and strategic development of critical metals, which is important for national security, green energy transition, advanced technology, and economic self-reliance. CRISP 2025 is conceived as a 360-degree platform that brings together academia, industry, government bodies, and policy makers to deliberate on science, technology, and strategic dimension of critical metals. Recently, IIT ISM Dhanbad has recognized as one of the centers of excellence under the National Critical Mineral Mission by the Ministry of Mines. Therefore, this organization of CRISP 2025 is most timely and marks a landmark opportunity to bring together eminent personalities and industry leaders working in this field on critical metals on a single platform. With this in mind, the conference has been designed in 6 technical sessions, each addressing a core area vital to India's Atmanirbhar journey in critical metals. This includes 22 invited lectures, 8 industry talk, 11 oral presentation, and 30 posted presentation, followed by a panel discussion on critical metals for India's future, policy, technology and industry pathways. We have around 300 participants, including 32 eminent speakers, 35 industry representatives and scholars from 25 institutions across India, which includes IITs, NITs, CSI Lab, GSI, etc. This reflects the growing momentum and multi-stakeholder interest in critical metals. With the generous support of our sponsors, we achieved in this path. Our platinum sponsor, GSRC, SSCL, diamond sponsors, ANRF, HCL, JCSTI, BRNS, silver sponsors, IRL, Elitech, L&T, Ashwini Magnet, IITech, and bronze sponsors, Polyprotech, Maheshwari Mining, CSIR, AMD, Aries, and Alpha Level. Along with Texman as our technical collaborator, we have succeeded in bringing our vision to reality. With this, I formally declare the National Conference on Critical Metal CRIS 2025 open. I welcome all of you once again. Let us use this 3 days event to share knowledge, to build bridges, spark innovation, and contribute meaningfully to India's journey towards a secure and sustainable future in critical metals. Thank you very much.
Thank you, ma'am, for that elegant and warm welcome. Next, I would like to invite Professor Shatrughan Soren, Chairman of CRIS 2025 and Head of the Department of Fuel, Minerals and Metallurgical Engineering, to address the gathering and share the department's vision for this crucial domain. So please.
Hello.
Respected Dr. V.K. Saraswat, Member, Niti Aayog, Government of India, Professor Sukumar Mishra, Director, IIT ISM Dhanbad, Professor D.K. Singh, Advisor of the conference, Professor Aarti Kumari, Professor Vishnu Teja, distinguished speakers, delegates, students, friends, ladies and gentlemen, Johar and a very good morning to all of you. It gives me immense pleasure to welcome you all in the National Conference in Critical Minerals 2025 organized by the Department of Fuel, Mineral and Metallurgical Engineering, IIT ISM Dhanbad. On behalf of Department of Fuel, Mineral and Metallurgical Engineering and my personal behalf, I also welcome you in the conference, and it is my privilege to welcome in the conference of the August gathering of scientists, researcher, industry professional, and as Professor Aarti mentioned, that theme of the conference, that is critical minerals recycling, innovation, separation and processing, it is both timely and significant. As the global economy moves towards clean energy technology, electric vehicle and digital infrastructure, the need of critical minerals and the strategic minerals that is increased manifold. So the ensuring this sustainable supply, efficient recycling and the use of that critical minerals, that is very, very important and significant for national and global. So our department, Fuel, Mineral and Metallurgical Engineering, has always been at the forefront to appreciate this type of effort. The department aim is to integrate fundamental research with industrial application, focusing in areas such as coal carbonation, thermochemical conversion of biochar, beneficiation of low-grade ores, the dry beneficiation, agglomeration of fines, processing of the critical minerals, additive manufacturing, cold spray and processing of materials. So we are continuously working to align our teaching and research with the national need. So from mineral processing, especially critical minerals, recovery of metal from primary and secondary sources, to the development of green metallurgical or clean metallurgical engineering. Through the initiative like this conference, we are strengthening the department's goal is a hub of innovation and knowledge transfer in the field of mineral and metallurgical engineering. So with these words, I express my sincere thanks to our chief guest. Thank you, sir, for gracing this occasion with your presence. And I also thanks all the participants, all the speakers, students who has joined us from different part of the country. Once again, I extend my warm welcome to everyone. Thank you all. Thank you very much.
Thank you, Soren sir, for your valuable words. It is now my great privilege to invite our visionary leader, Professor Sukumar Mishra, Director of IIT in Dhanbad and the patron of CRISP 2025, to deliver his address for the conference. We look forward to your insights and we are all ears, sir. Please welcome him with a round of applause.
Good morning, dignitaries on the dais. Dr. E.K. Saraswat sir, our chief guest. Dr. T.K. Singh, who is recently joined with us as Professor of Practice and also a visiting professor, and his critical thinking in the domain of critical mineral from the sphere of nation will definitely help the institution and the country as a whole. The convener, HOD of the department, other faculty members, invited members, media, and my dear participants in this conference. HOD has already mentioned about critical mineral, and he has also mentioned about the need of critical mineral. In that context, it is also pertinent to mention that IIT Dhanbad has been chosen as one of the center of excellence in the critical mineral aspect. Recently, our Prime Minister has also mentioned in one of his address that the critical mineral observatory with India, UK coming together with Cambridge University is going to be set up at IIT Dhanbad. So these two things which has come in the near past has given a lot of responsibility to the faculty members, students, and other people involved in this institute, as well as their counterparts across the nation as well as international. This responsibility, I am sure, our team will be able to handle, and in the process, as already told by the organizer of this conference, we will march ahead towards Vikasit Bharat. It is also pertinent to mention that we are looking for clean energy, and in the clean energy, many options are coming. I am also not sure that which option will be ticked by the market and will be accepted by the user of those energy. Since society is not yet clear, citizens are not clear, nations are trying to reach to different directions. So there is a transient state going. This transient state will definitely see a steady state phenomena in very near future. This steady state phenomena, when reaches from the transient movement, there lies the control action. And whether you will move in a first order manner or second order manner depends on the control actuation that you are going to provide. And in the critical mineral, the control actuation is nothing but this gathering who will give input to the control system, which is the intellectual base. So, that control action need to be analyzed, need to be pre-tested, need to be adaptive, and need to be intelligent. I am sure in our institute we have that capability to decide about that actuation, and this conference is the starting point of that control action. I must thank the conference organizer for starting a debate on this critical parameter, and we have to see whether that actuation is going in a controlled, guided direction or not. There will be many disturbances, there will be many obstruction on the path, and we must make disturbance rejection algorithms so that it will be fruitful ultimately and we'll be able to see the light of the day. Thank you for coming over to IIT Dhanbad. Special thanks goes to the dignitaries, speakers who had come on all along from different parts of the country to make this gathering a gala success. At the end, I must give my special gratitude and thanks to our chief guest who has taken a lot of pain to come to Dhanbad, flying just one day back from abroad and going to Gujarat next day and again coming back to Dhanbad. Thank you, sir, for taking so much pain to reach IIT. Jai Hind.
Thank you, sir, for your inspiring address. We are truly honored to have with us a distinguished scientist and an eminent personality as our chief guest today. To do the honors of introducing our chief guest, may I now invite Dr. D.K. Singh, Advisor for CRISP 2025.
Good morning to all of you. It is indeed an honor and privilege for me to introduce our beloved chief guest, Dr. Vijay Kumar Saraswat, member Niti Aayog. And before that, actually, I would also like to express my sincere gratitude to you, sir, personally, to come to IIT Dhanbad. The director sir has already told about it, but I also express my sincere gratitude to come here. Now I will just read out the biodata. Yesterday also we had in the text me, but again, for many new faces are there. Dr. Vijay Kumar Saraswat, a highly esteemed scientist and member of Niti Aayog, renowned for his extensive experience in defense research, encompassing both fundamental and applied research and science research, having served as a secretary of the Defense Research and Development Organization (DRDO), he has made remarkable contributions to the indigenous development of missiles like Prithvi, Dhanush, Prahar, and Agni 5, as well as the two-tiered ballistic missiles defense system. Dr. Saraswat played a pivotal role in establishing infrastructure to support the nuclear doctrine, developing cyber security technologies, and enhancing the national defense capabilities against ballistic missile threats. Furthermore, he has been actively involved in the development of alternative energy systems such as clean coal technology, concentrated solar power systems, and bioenergy, hydrogen-based economics. he has been pursuing major initiative in the sustainable and resilient transportation system which e-vehicles, FCV, hybrid vehicles and hydrogen-powered long-haul transport systems. Dr. Saraswat has also made significant contributions to the achievement of technology, including the development of silicon photonics, the configuration of the processors for ICT applications, and the roadmap for the Indian Railway Research Institute. As a member of Niti Aayog, Dr. Saraswat has initiated methanol economy program aiming to utilize methanol for transportation, energy generation, and chemical production. Additionally, he has chaired committees on technical, textiles, body armor, contributing to the futuristic growth of these sectors in the country. Dr. Saraswat's outstanding achievements have been recognized through numerous awards, including Padma Shri and Padma Bhushan, as well as honorary doctorate from 27 universities. Distinguished professor at IIT Hyderabad and IIT Roorkee. Recently, he was elected as a Fellow of Indian National Academy of Sciences, awarded Fellow of Eminence of World Academy of Higher Education and Development, WA Head, on the World Teachers' Day in 2024. Dr. Saraswat has worked in the basic and applied scientific areas for nearly more than 40 years and has made significant contributions to the development of indigenous missiles and other defense equipments. With this, I just request Sir to come and give his.
Very good morning, namaskar. By the time they bring my computer, let me convey my greetings to the director, sir, my dear friend, Professor Sukumar Mishra, another friend, Dr. D.K. Singh, actually Mr. Shatrughan Soren, and the organizer, convener for this, Professor Aarti Kumari, and some of my very distinguished friends who are sitting here, Dr. D. Singh, Vermaji, Tiwari, all the faculty members of ISM Dhanbad. I always like to continue calling it ISM Dhanbad. Sorry to say that. I'm not used to calling it IIT ISM Dhanbad. So, yesterday, I had an interaction with the faculty members of IIT ISM Dhanbad. It was a very good discussion. Almost an hour we spent together discussing what is needed by the country to meet the challenges in the areas of critical metals, minerals, also ensuring that whatever research we do today, it finds application in the industry and ultimately contributes to the economic growth. Many issues were discussed, many questions were raised, and we had tried to bring some direction in which the work should proceed. Now I'm going to talk to you about the topic of today's conference, that is critical metals and minerals. talk to you about what is critical about it and why critical metals forms the basis for ingredients and that necessarily support the pillars of Viksit Bharat. The fact that the government of India has become vigilant about the requirement of critical minerals and metals is mainly because we are looking at Viksit Bharat 2047. If India has to become a 5 trillion economy by that particular time, it cannot be done unless we go into various aspects of energy production, fuel production, in terms of manufacturing, in terms of digitalization, in terms of smart transportation. In all these areas, we need to use materials and minerals which are very important. And they are called critical because of the fact that they are important for various aspects and they are required in numbers. Unfortunately, we have issues with respect to their availability in the country. So there is a high risk of supply chain disruption that is likely to happen because most of it we are importing today. And today if we are looking at transition to sustainable and low carbon existence, which is what is another goal we are setting for ourselves, that we will net carbon zero by 2047. Sorry, 2070. In a situation like that, the materials and minerals which are required for renewable energy, smart transportation and all that have a huge supply list. The graph indicates what are the major materials which we need for energy transition. Dr. Sukumar mentioned about the energy transition, what we are talking about. The term critical reflects a confluence of economic indispensability, risk of supply disruption and the lack of viable alternatives. We don't have those alternatives and that's why we are worried about it. What are the factors which are influencing the criticality of these minerals? Obviously, it is with respect to availability of various reserves and the production capacity what we have today. They are all required for energy low carbon transition. Their location, quality, and depletion rates of ores and minerals is a question mark. And they are also very important for the national security considerations. I come from defense background, as has been indicated by the introduction given by Dr. Singh about my work. I can only tell you right from the days of 80s when we were building missiles. Materials used to be one of the major areas of our concern. Yesterday night we were talking about magnesium. Magnesium is a light material which we use for aircraft as well as in the missiles. We used to import magnesium plates from Germany. And the moment we launched first Prithvi, there was an embargo by Germans in supplying the magnesium plates to us. The wings of my Prithvi missile were made out of magnesium plates. One of the sections, the major airframe structure was also made out of magnesium casting. So neither we had powder nor we had plates. And we were put into inconvenience and difficulty because supply chain disrupted. Now, one can certainly look back and say, what can I do? But our country, and in those days under the leadership of Dr. Kalam, we said, no, we'll find ways and means of getting magnesium. With the help of DMRL, my sister laboratory in those days, and there was an industry in Hyderabad called Superinductive. I don't know whether Verma ji and others may remember that. And TIDCO is Tamil Nadu Industrial Development Corporation. TIDCO was in those days trying to get from the seawater magnesium in a small plant. So we went and made it bigger, and we started getting magnesium ingots. Those magnesium ingots we supplied to DMRL. They converted them into powders and alloys, because we needed not pure magnesium, we needed magnesium alloys. And from that source, we were able to build castings and also convert them by rolling into plates, and hence the program continued, of course with delay. But the kind of R&D that went into getting magnesium from the seawater and also doing the complete processing of that powder into castings and plates was set up in that process. So complete country became self-reliant. And this news spread around, and I want to tell you, the same Germany which had stopped the supply agreed to give the same plate at half the cost. So what is the message? The message is no foreign nation wants you to actually become self-reliant. The fact that they reduced the cost and they are ready to supply at half the cost was basically to kill my program of producing that magnesium in the country. So national security considerations were very important. If I am going to do tomorrow AMCA program, Advanced Medium Combat Aircraft, the number of minerals and metals which are listed for that are enormous. I need some of the very exotic nickel alloys, inconel, this, that and all that, so many, and composite materials. So they are all critical. They are essential for the clean technologies. All of us know that if I need solar power, I need all the critical materials. If I need hydrogen production, I need for my electrolyzers critical material. If I need any of the other fuel cell manufacturing and things like that, I need large number of critical materials. And hence they are very important. We have to have a competitive advantage also. If our products have to compete in the market, we have to ensure that the cost of these critical minerals and materials is competitive, and they should meet my industrial development objectives also. That's why all the R&D which is done is basically to become import independent and also reduce the supply chain vulnerability. The kind of metals which we are looking at in critical materials are nickel, cobalt, lithium, rare earth metals, and many neodymium and so on. We also need non-metals, we also need chemicals. I won't go into that because they are all subsets of the critical materials what we are talking about. Now, among the critical metals, due to the rapid industrialization, energy transition and push for net zero, as I mentioned, they are indispensable, and modern industries, particularly clean energy, digital technologies and strategic defense systems require them. Why they are critical? One is in terms of their availability. Another thing, we cannot do without them because of their specific properties. They have got high energy density, they have got strong corrosion resistance, they act as catalysts, they act as a magnet material, and so on. So for a variety of applications, we need these critical metals and minerals. If you see what is the rate at which the usage has increased from the year 1700 to the year 2000 and beyond, all metals, right from actinoids to non-metals to semi-metals to basic metals, transition metals, alkaline materials, all of them have gone up. You can see the pyramids going up and up and up. And this is because of the various areas in which the utilization is taking place, right from the wind energy to the kind of industry applications to automobiles and so on and so forth. This is how we need for different applications in the global economy for increased supply, and it's not just about consumer electronics, but it is about energy transition, indium, gallium, selenium, neodymium, dysprosium, all are needed in various solar energy, wind energy, As I mentioned to you in the defense and national security, right from rhenium to germanium to gallium to arsenic, and most of them are needed for aircraft and hypersonic missiles, for electronics and so on. And today's transportation system, all of you know electric mobility is demanding lithium in a big way, cobalt in a big way. An advanced ultra-supercritical thermal power plant which you want to set up is based on alloys for high temperature, needing almost 42 to 47% nickel in that system, so you would have a huge quantity of nickel. And even our own healthcare, where you are having MRI machines and so on, use a lot of these minerals and materials. So transportation, healthcare, like europium, tungsten and cerium and terbium and yttrium, all these materials are needed. And I only know that most of it are not available in our country. This is the application wise. We need, for example, neodymium, praseodymium, dysprosium and terbium for magnets for the wind turbine, generators and EV motors. Cobalt, lithium and nickel for batteries for electric vehicles. Iridium and platinum for electrolyzers for green hydrogen production and fuel cells for energy storage. Gallium for semiconductors that enable high voltage power and effective lighting. Magnesium, as I mentioned too, as a lightweighting alloy for transportation and aircraft applications. And these are all towards the goals which we have set up, like 100% clean electricity by 2035, net zero economy by 2050, EV adoption by 2030, 30 gigawatts of offshore wind by 2030, and cost of clean hydrogen to be reduced to less than $1 per kg by 2031. These are the goals we have set up. Very, very ambitious goals, but all this would require these materials. Government has made a list. Dr. Mishra mentioned about the National Critical Mineral Mission. In that Indian context, we have 25 almost materials. Earlier the list was 35, it has been reduced to 25. And platinum has been added in that, and all these materials are required basically because of the high economic importance, high supply risk and high economic importance plus high supply risk. All of them are there in different colors, indicating that if we don't have these critical materials, our economy will suffer drastically. Now, what is the position as far as the availability of these materials in our country is concerned? So I tried to give you a list and also the map where all whatever little materials are available. For example, lithium, the location is Riyasi, Jammu and Kashmir, 5.9 million tons inferred, G3 state. Katbora, Chhattisgarh, G4 state exploration initiative. Rare earth, Andhra Pradesh and Rajasthan, these are the two places. Again, monazite bearing sands and alkaline rocks. Cobalt, Singhbhum belt, Jharkhand, low grade occurrences. Nickel, Odisha, Sukinda Valley, in the form of sulfide ores, limited scale. Tin is available in Bastar and Chhattisgarh. Molybdenum in Tamil Nadu and titanium in Kerala and Tamil Nadu coast. So these are the possible places where we have some reserves as indicated in the survey which was done in 23-24. The problem with our minerals is that the concentration of these basic minerals is very, very small. If you compare ourselves with the other countries like Africa, Canada, Australia and Afghanistan and all this present, the percentage of these metals in the ore is very low. So it requires special technologies by which you should be able to extract the minerals. And the whole extraction process is listed here. Starting from the geological resources, we do the exploration, then go for development of that place, then in the mining operation. From the mining operation, we go to the ore processing, and then people all come there for metallurgy, refining, purification, then semi-finished products, components and end product. And in between you have the waste coming out from different locations. For example, waste from the semi-finished product, waste during the purification, waste during the component, so production waste collection. So and all of them can then be put into the metallurgy refining process, preparation, dismantling, crushing and separation. And from the end products, you can take it as the end of life product as a waste and then recycle it. So secondary recycling is the process what you can do. Primary versus secondary resources. The primary I mentioned to you, extraction of metals directly from natural mineral deposits. There could be hard rocks or sedimentary deposits or tracer deposits. As far as the secondary resources are concerned, today we have a huge e-waste available. And I can tell you the smartphones, the laptops, the circuits, the electronics, what we have a huge quantity of these very, very precious metals available. And we have to extract. Unfortunately, our efforts in this direction have not yielded the desired effect, but some industries are coming up today. But even today, the printed circuit boards which are there in our country in the e-waste are being sent abroad for processing. We are not manufacturing. Where some of the industries are trying to now set up factories for getting the minerals, the metals from those. Spent batteries, I find some very good startup companies who are working on lithium-ion batteries. Yesterday also we met people, some youngsters who are recycling the lithium batteries. Then industrial scrap, getting from the catalyst from there, the metal residues from manufacturing and so on. So these are some of the areas where we can extract material from the secondary sources. Then the other process of metal extraction is beneficiation, which refers to the suite of processes used to improve the economic value of an ore by removing gangue minerals and increasing the concentration of valuable metals before refining. It enhances metal recovery, reduces processing volume, and improves environmental efficiency. Comminution reduces the ore size to liberate. Physical separation methods like gravity, magnetic, flotation, and electricity separation, and concentration and dewatering processes. The metals which can be removed from this key beneficiation methods are lithium, cobalt, rare earths, and nickel, using the processes which I mentioned you just now. What is important is value addition and alloy development in critical materials. You may get lithium, but I need lithium iron phosphate. You may get nickel, but I need inconel. So I need various alloys in different forms. So value addition refers to the processing, refining and transformation of raw or concentrated critical metals into intermediate or final products which derive higher economic value and functional advantage. So for that, you take a mineral concentrate, refined metal, functional material, and then of course advanced components to make. They are also alloyed to give the required properties like hardness, strength, corrosion resistance, thermal conductivity, and electrical conductivity and so on. Some of the typical alloys which are used in various applications are superalloys. Our Midani is our center for superalloy production, you know that. They make nickel, cobalt, rare earths, which are needed in jet engines, turbines, space components. Battery alloys like lithium, nickel, cobalt. Magnetic alloys like neodymium, dysprosium. I see one of the companies who is now venturing into making the metals like neodymium and dysprosium and also converting them into magnets. But I think they are only doing the resin bonded. I want them to do the sintered magnets also. Corrosion resistant, titanium, molybdenum. So these are some of the minerals which are there. Now in this process, what is the kind of market which is there for this? Because everything has an economic value. If you don't have market, then people will not work for it. Lithium alone is forecast to be about $400 billion market by 2030, rivaling today's steel or oil and gas by revenue consumption. And these are, the table gives you the lithium, copper is how much, about 400 to 500, at a CAGR about 5 to 7%. Lithium is highest, 25 to 30% CAGR. Cobalt, 90 to 100 billions, 15 to 18% CAGR. Nickel is about 150 to 170 billion dollars, 10 to 12% CAGR. Rare earths, of course, 40 to 60 billion dollars, about 15 to 20% CAGR. Estimated global market that is there in 2030, that is what we are talking about. So there is business, and it is not that business is not there. So if we make investment, if we develop technologies which are essential for all this, if we are able to extract whatever little what we have in our country, I think there is market for that. Now, what are the challenges for India related to critical metals? All of you know it is import dependence and geopolitical risk. Our main problem is, we have been discussing since yesterday, time lag. In whatever we do, we have a huge time lag. And the world is moving fast. If you don't take the right decision at the right time, the vehicle will continue to roll and you will be left behind. Underfunded exploration. Our funding on exploration efforts is low. Gaps in institutional and policy landscape. ISM Dhanbad is a typical story. ISM Dhanbad, yesterday I mentioned this, was the only school of mining available once upon a time in the country with a human contribution. We have reduced its work and then increased the work by calling it IIT and now teaching all kinds of other subjects which otherwise could have been taught by any other institution. So these are all gaps in institutional and policy landscape. We certainly have a limited domestic reserves, so we should go and acquire reserves from outside. And we are all looking at sustainability, high emission scenario. That is what we are, that's a challenge for us. Circular economy is very important. The process shown here is extraction, primary metal production, material market, and from there you make component market, product production, and product market, and product use. That is the simple process, and finally waste happens. Now from each of these stages, right from the product use, you can go for reuse. Right from the product market, you can use used goods market, and you by repair. You can also do remanufacture, and you can take the used goods, convert them to scrap, recycle, and bring it to the material market. So the complete circular economy will enable a lot of economy, both in terms of product circularity as well as material circularity. So that's more important. The remanufacture, refurbish, repair, reuse, recycle, and repurpose should become the order of the day. We should design with reuse capability, we should increase recovery capability, we should minimize waste, and we should also increase recycling rates. These are all important part of the circular economy which everybody has to learn how to do. Then there are lots of potential waste which are in a position to give you a lot of critical materials. Recently we have been able to do that work using the red mud which is available from the aluminum processing, and we are able to extract some of the rare earth materials. Similarly, coal, waste coal, acid mine drainage, this is another source. Ash is another source. Petroleum refinery waste like desalter and coke can give you nickel, vanadium, molybdenum, and heavy crudes. Red mud I mentioned to you. Smelters can give you many critical materials within flue dust and slags. Mine tailings, product waters from oil and gas production can give you lithium. Municipal solid waste. In fact, there is a lot of effort on doing extraction from the municipal solid waste. But somehow, because of the economy, people have not been able to give a major push to that. Municipal sludge is a potential source of platinum group of metals. E-waste, source of platinum group of metals and critical materials. They are available. I am talking to ISM, so I thought it is important that we should also tell at least the students who are not working in the area of mines and minerals, the kind of challenges of technology what we have in extraction and recovery. The technologies which are needed for extraction are hydrometallurgy, biometallurgy, ionic liquids, electroleaching, supercritical fluids, and for recovery, you need processes like solvent extraction, ionic liquids, biosorption, ion exchange, precipitation, electrochemical, and direction recovery and recycling. Secondary source I mentioned to you, we can get all these items like rare earth, lithium-ion battery technology, metals, platinum, gold. So a robust recovery ecosystem involves both extraction and refinement technologies, tailored to secondary sources such as bioleaching, solvent extraction, and ionic liquids. These are the areas in which I think we have to make our younger generation ready. If these technologies are not perfected, and these technologies are not applied to the Indian ores, to the Indian sources, we will not be doing the justice. So I request the IIT, ISM to have special curricula, special courses in these and train our children in these technologies and help the industries to set up the processes for manufacturing at large quantities. So we have National Critical Mineral Mission 2025, which comprises several key components designed to ensure a sustainable, resilient and self-reliant critical minerals value chain in India, aligning with Viksit Bharat, as I mentioned. What are the initiatives that are taken? Increasing the domestic critical minerals production. That is one of the focus. Second one is increasing domestic critical minerals production. Another focus. Recycling of critical minerals, trade and markets, scientific research and technological advancement for critical minerals. Why I am saying that this is a requirement? Because many of my academic friends here and the PhD students are looking for resources for doing research. So under this program, you should be in a position to extract this money and use it for your R&D activities as well as for your human resource development and also for developing effective funding, financial and fiscal incentives that is a part of this program. So there is enough which is available now and it's up to us to make use of that and do R&D in a big way using the Indian sources. So these are some of the upcoming policies of the government of India which are helping critical mineral market. We have finalized the 3,500 to 5,000 crore scheme to incentivize production of rare earth minerals and derived magnets in the country. Finalizing an incentive scheme for recycling critical minerals like neodymium, dysprosium and terbium and samarium. A scheme to incentivize the recycling old permanent magnets with allocation of almost about 1,500 crores is under the approval stage. Amend the Mines and Minerals Act to support extraction of mine tailings, and District Mineral Foundation Trust working on mission mode to expedite operationalization of mines by reducing time taken at every stage, right from mining lease to approvals to operationalize. I think the last one is very important because one of the major things what in India we have found is after the auction is over, the process of actual mining may take anything between 5 years to 10 years, and sometimes it doesn't even proceed after 10 years. Because the kind of processes involved in getting clearances from forest, from pollution, from waste, from variety of state government rules and regulations, so critical, so complex that it takes a huge time. I think there is a need for us to do something about it. IIT Dhanbad has a role to play in this particular area. And I am very happy that it is enabling India's transition from a resource-based economy to a high-tech, self-reliant, sustainable industrial power in alignment with the Viksit Bharat 2047. As all of you know now, it has been announced, you are a center of excellence under the NCMM by the Government of India. You also have a good incubator research park called TechSpin, which is Technology Innovation and Exploration and Founding Foundation. And research into various applications like mapping the untapped domestic resources, mine tailings, industrial waste, developing beneficiation and recycling technologies for low-grade ores and industrial residues, using artificial intelligence and machine learning for data-driven exploration and traceability systems, partnering with industry to bring lab-scale solutions to field-scale applications, and upskilling youth and enabling startups in mining, metallurgy, and circular economy. To conclude, I would like to give a way forward, and that's very important. Because if we have to really move, we have to do some important, we have to take some important steps like secondary resource valorization, develop advanced solvent and bio-leaching techniques for recovery, develop purification and selective separation, low-grade ore processing, since yesterday I am telling, formulate beneficial protocols for ores with less than 1% metal content, optimize thermochemical and hybrid approaches for complex mineral matrices. Third one is next generation refining technologies and AI integration has to take place. We should explore membrane-based separations, electrochemical extraction, and low temperature hydromet routes. We should develop green chemistry protocols using ionic liquids and DLE analytes. We should integrate real-time process monitoring systems in lab-scale metallurgical flows. These are some of the suggestions which a non-metallurgist can give. I am quite certain that many of the great scientists in metallurgy who are sitting here, many of the faculty members who are sitting here, who have been practicing these processes, they should be able to bring it as part of the curriculum. They should set labs for demonstrating these processes. They should carry out research for these processes. They should create a human resource for solvent extraction and things like that, which has become almost a distinct entity today, so that our country should be able to move forward as far as the critical metals and minerals are concerned. Friends, unless IIT ISM takes major initiatives in these areas, and all the young people who are here, in addition to learning computer science, they also learn computer science along with the metallurgy and other processes. We will not be able to meet this goal of achieving self-reliance as far as critical minerals and metals are concerned. Fortunately, the government has given funds. Fortunately, they have tried to create an ecosystem. Now it is up to us to come together, work together in a collaborative mode with the industry. Take all your laboratory processes which you develop here through the innovation cycle, because your conference also talks of innovation, through the innovation cycle into the market. Set up pilot plants, don't go into only lab scale. Even in ISM, you should be able to set up pilot plants, maybe half a ton per day or maybe 100 kgs per day. I have no problem, but something which can be replicated by the industry, taking cue from the technology elements which you are developing. Unless we are able to translate your work, bring it to the market, attract the industry in that direction. We can also tell you that if we are able to produce these critical minerals at large quantity, even though they may be costlier than the Chinese metals, we will be able to put certain amount of duties and bans on import and ensure that the indigenous materials are used. So government is going to come forward for creating the ecosystem. It's up to us now to make use of it. And I believe that the faculty, the researchers, the students, the industry should come together and make this venture a success and make India independent as far as the critical minerals and metals are concerned. Thank you.
Thank you so much, Doctor, for that incredibly insightful and thought-provoking address. I'm sure all of them have got a gist about what critical metals is, and we deeply appreciate your efforts for sharing your knowledge with us. Your words have truly set a powerful tone for this conference. I request the dignitaries to take back your seats on the dais.
We now move to a significant moment of the ceremony, the official unveiling of the Book of Abstracts, a compilation of all the talks that will be presented over the next 2 days of CRISP 2025. I request our chief guest, Dr. V.K. Saraswat, and all the respected dignitaries on the dais to kindly unveil the book.
of abstracts is the embodiment of years of profound research from the visionaries and experts. Thank you so much. A conference like CRISP is not just a platform for presenting research, but for forging the future too. We now arrive at one such pivotal moment, where we formalize a commitment to powerful alliance. Under the Critical Mineral Research Initiative, IIT Dhanbad is collaborating with Mini Mines Clean Tech Solutions, Polyprotic Chemicals Private Limited, and Sun Technosis Private Limited through formal memoranda of understanding. This collaboration brings together the academic excellence of IIT Dhanbad and the industry expertise of its partners to drive innovation in material discovery, pilot scale development, and sustainable technology solutions for critical metals.
Now, I would like to invite respected Professor Dheeraj Kumar, Deputy Director, and Professor Parthasastri Das, Dean, Research and Development, along with the CEO, Mini Mines Clean Tech Solutions, Mr. Anupam Kumar, to kindly come forward on stage for the exchange of Memorandum of Understanding.
We kindly request the dignitaries off of the dais to please come on stage in order to oversee the proceedings. We now call Mr. Rajesh Goyal from Polyprotic Chemicals Private Limited to come on the stage.
Now I would like to invite Director of Sun Technosis Private Limited, Mr. Vaidiswaran on stage to kindly come forward on stage for the exchange of memorandum of understanding.
Thank you, esteemed dignitaries. This collaboration marks a significant step forward. You may now please resume your seats. As a gesture of our deep respect and gratitude, we would now like to felicitate our Chief Director. May I request the Director, Professor Sukumar Mishra, to present a memento to our Chief Guest, Dr. V.K. Saraswat. The shawl and memento would be presented by our Director, sir.
Thank you, sirs and ma'am. We are truly grateful for your presence. An event of this magnitude is the culmination of tireless efforts from many individuals. To express our gratitude, I would like to invite the co-convener of CRISP 2025, Professor Vishnu Teja Mantripragada on stage.
A very good morning to the dignitaries on the dais, distinguished invitees, esteemed scientists and industry professionals, my faculty colleagues and students from IIT ISM Dhanbad. A warm welcome to all of you to the CRISP 2025 inaugural ceremony. Since we are running a bit behind schedule, I'll keep my remarks brief out of respect of everyone's time, but please don't take my brevity for lack of gratitude. My thanks are as heartfelt as ever. As a co-convener of CRISP 2025, I am delighted and I am privileged to propose this vote of thanks for this successful inaugural ceremony. The inaugural address by our Honorable Chief Guest, Dr. V.K. Saraswat, has set an inspiring tone for this conference. In light of the recent global developments surrounding the supply and trade of critical metals, Dr. Saraswat's insights and recommendations for the way forward have highlighted the strategic national importance of this field and the sector for our future economic and technological advancements towards self-reliance. Sir, we are deeply grateful for your presence and your valuable insights. We extend our sincere thanks to the Director, Professor Sukumar Mishra, for his support and continuous encouragement. Our sincere thanks to the Deputy Director, Professor Teja for his prompt support and unwavering commitment towards making this event a success. We express our sincere gratitude to Dr. D.K. Singh, Advisor, CRISP 2025, for his pivotal support in organizing this conference at this scale and bringing together leading researchers in critical metal extraction and refining. We also thank Professor Shatrughan Soren, Head of the Department, and Professor Shravan Kumar, former Head of the Department of Fuel, Minerals and Metallurgical Engineering, for their valuable support at every stage. I would like to acknowledge the excellent collaboration and partnership of Professor Aarti Kumari, the convener of this conference, for the successful organization of this event. We sincerely thank the National Advisory Committee members and the organizing committee members for their time and valuable inputs. We sincerely thank all the invited speakers for taking their time out of their busy schedules to attend this conference here at IIT ISM Dhanbad. We gratefully thank our sponsors and technical partners for their generous financial support, which made this event possible. We extend our thanks to all the staff members of the Department of Fuel, Mineral and Metallurgical Engineering, and a special word of appreciation goes to our student volunteers. Their energy, discipline and long hours of work behind the scenes has ensured that every task was completed on time. Kudos to you. We also acknowledge the support of administrative, hospitality, and security staff for a crucial contribution in the seamless organization of this conference. We also thank the press and media for their timely coverage of the event and for their continued support. Above all, we thank all the participants who have physically joined us here and those of the participants who have joined online, whose presence and encouragement and engagement gives meaning to this conference. Finally, I'd like to extend my heartfelt gratitude to everyone who has contributed directly or indirectly to the success of this event. We look forward to insightful sessions and discussions that will advance research and foster innovations in the field of critical metal extraction, recycling, refining, and so on. Thank you very much.
Thank you, Vishnu sir. We have now reached the conclusion of our inaugural ceremony. I kindly request everyone to raise from their seats for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
You may kindly take your seats. We invite all our esteemed dignitaries for a group photograph on the stage, while the participants kindly stand in front of the stage.
The dignitaries, please come on stage.
सर आप लोग थोड़ा सा बैठ जाए भैया सेल फोन थोड़ा थैंक यू सर
बीच में चले जाइए बीच में
एक मिनट